I've known John for quite a long time, and I don't know what a Wednesday night Digifest is.
I
So
finally found a,
please reveal, John.
I, fa-
Reveal all.
I finally found a topic that John doesn't know something about. Uh, can you all hear me? Oh, crikey. Can you all hear me, including at the back? Good. Well, this, I was a bit worried when I saw this title in the program with no explanation as to what it was, but this talk is about digital modes above a gigahertz. Some of the issues involved, because I think a lot of you, hands up who does digital modes? Hands up who does digital modes on VHF? Oh, we're getting there. Good. Okay. So some of you know what I'm talking about, hopefully. Because of my interests, I tend to operate above a gigahertz. That's not the main reason I operate above a gigahertz. I'd love to operate on 2 meters, but as you can see, my antennas are only 8 meters above ground level, and it's a wall of pain and noise on 2 meters and downwards in my QTH. I'm surrounded by houses, so I've slowly migrated upwards. So, but I thought all this FT8 stuff and interesting things is very good, but there's no activity much on the digital modes apart from EME. On the gigahertz bands, a lot of the activity on EME is digital, especially with small stations. And I got into it because of small station EME, but I thought let's try it on the other bands and let's look at some of the issues. So about a year ago, I initiated a thing that I laughingly called the Digifest, which was an informal Wednesday night get-together with a few others, Neil G4, DBN, people throughout the UK who'd got 23 SEMs. And I talked about it in my column back in 2017 to try and generate activity above a gigahertz. Because it's great fun on the bands above a gigahertz, but there's a real problem with it at the moment in that all the activity is once a month on a Tuesday night. And if you do the arithmetic, the number of times I hear people saying, I never work any DX on the gigahertz bands, but if you do the arithmetic of, first of all, take how often tropo and good openings occur, multiply it by the number of days in a year, and then divide that number by about 100, which is probably 3 days a year that you get on a particular band in a contest. So I was trying to generate some activity, and I thought, well, let's combine the two. And it took off a little bit, and then I had a long summer where I couldn't do much this year. But I think there's still some people around, and I'd like to try and get it going again. So it's an evening where we play digital modes on the gigahertz bands. It's a sort of an informal gathering. There's no contests. There's no scoring. We all sit on around about 1296.165 plus or minus a bit. And we sit on the ON4 KST chat, which I'm sure you're all familiar with. And we just play with propagation in different modes. We've had contacts with aircraft scatter, with tropo, with rain scatter on digital modes. And it's a sort of thing you can drift in and out of because people call CQ and you can call CQ, but it is quite different to the FT8 type of operation that some of you will be involved in. The other thing is there's a serious threat to the gigahertz band. If we are not careful, we will not have any in 10 years' time. And I'm not just saying that to be scary. I honestly believe that. There is serious pressure on all bands above a gigahertz because it's the sweet spot for mobile phones. So activity once a week, once a month, does not hack it with these bands. And Ofcom are going to be looking at this and they're going to be saying, there's nobody on here. About 2 years ago, they gave us a complete new 2 megahertz band at 2.3 gigahertz. And this by NOV, and they said, there you go, you can run 400 watts, no limitations, no distance limitations, off you go. There's probably 3 people who've had QSOs on that band in that 2 years. And what's going to happen when the NOV runs out is they're going to say, oh, okay, well, sorry, we're going to take 2320 now for cellular phones, like has happened in Sweden and places like that. And 2300, yeah, nobody's using that, so we'll have that as well, please. So that's a serious threat, hence the picture of the lady with the gun holding a gun to your head. So all this Digifest is in this as a background. And like it or not, digital modes are here to stay. Some people, I'm not going to get into a fight about what's digital or get into mode wars as Neil called it yesterday. They're here to stay, so we might as well do something about it. And we might as well use them to generate activity. So, what did the digital modes ever do for us? I took this photo in somewhere overseas, and there was a whole load of Romans sitting in a cafe, so I thought that was rather appropriate. So, digital modes, what have they done for us? The first thing that they did, and the thing that got me into EME, is they've opened up EME for small stations. 99% of the people sitting in this room would not be able to do EME without digital modes. John can, and maybe a few others who've got big stations can, but for the majority of people, digital modes, EME was an exotic thing that people with 10-meter dishes did. It's not the case now. You can do EME with a 1-meter dish or less. The other thing they do, and I'm sorry, I see Roger's here, so I apologise, they give a viable alternative to CW for real gigahertz DX. There's nothing to beat CW for the gigahertz bands, and most gigahertz operators are average but competent CW operators. They have to be. But there is an alternative now if you've not gone and learnt Morse. So digital modes give you an alternative to get that extra few dBs. They've made beacons more interesting. Instead of just having a call sign every now and again, you can monitor them. You can see what signal strength they are. You can see what signal to noise they are. A lot of beacons are running digital modes, especially on gigahertz now, right up to 24 gigahertz and above, with a couple of beacons in this side of the country. They've opened up aircraft scatter. Again, aircraft scatter is something that you can do on CW quite easily. You can do on SSB if you have the technique. And with reasonably competent fast CW, you can do aircraft scatter. But with digital modes on 23 SEMS, it's easy. It's a whiz. So it's opened up that to people who don't have big stations. And it's made Joe Taylor infamous. K1JT. I mean, Joe Taylor is so famous that some people want to... That's not photoshopped, by the way. That really was a car parked in Station Road in Cambridge. I just could not believe it when I saw it. So, it's made Joe famous, but for those of you who can't see it, the registration number is KI55WJT, KISS WJT. So, they've done a lot of things to amateur radio. They're not everybody's cup of tea, but they have done some interesting things. So what sort of options have we got? There's a huge jumble of different modes, and when you first start on this, like when you start everything, what do we use? Hundreds of different modes, JT9, QRA64, all these terms you'll have heard over the last day or so, people talking about these things. There's almost a no-brainer choice for below 2 meters these days, and that's FT8. But we start getting some interesting things happening when we get into the higher frequency bands, and Neil touched on this yesterday. If you remember, he showed, those of you who went to Neil's talk yesterday, he showed, yes, and this morning, he showed some pictures of the effects of aircraft scatter on FT8 signals. Well, think of that in spades when you get onto the gigahertz bands. So let's look at what we need, and it's all down to the propagation path. Gigahertz bands propagation is unlike anything else in that it's usually a mixture of lots and lots of different things. It's a mixture of tropo scatter, tropo, aircraft scatter, rain, all these things. And that's what makes it so interesting, or to me anyway. It's a mixture of different propagations. So, and a lot of these propagation modes have interesting effects. A typical gigahertz path is subject to fading, multipath, short bursts of signal and then nothing, Doppler frequency shifts, huge Doppler frequency shifts when you get to 10 gigs. You can go right out of the passband very easily on a CW station with Doppler shift. And random frequency spreading. And this is a JT4F QSO between me and G4KVT that G4DBN received. That should be 4 tones. And that's what comes out of your loudspeaker on a normal over-the-horizon path on 23 SEMS. So Mr. Taylor's software, or our Danish software, has to sort out that. And you can see it's got spreading. You can't see the tones. It's got a complete Doppler shift of the original signal. Plus it's got, that looks like there's 3 separate tracks there. And I've only got to point my antenna in the opposite direction from GB3 3MHZ, the Martlesham beacon on 23, or over the hills to the Dunstable beacon on 23. And often I can't find the carrier. There are 5, 6, 7, 8 different aircraft scatter carriers, all shifted in frequency, and it's very difficult to tune to the actual carrier frequency mainly because of aircraft scatter. So you don't get this sort of thing on HF. You don't get this to the same extent on 6 and 2 meters. But when you get above a gigahertz, you're really dealing with multiple paths. So, and the higher in frequency you go, the more this happens. 24 gigahertz is a interesting band. There's a couple of people here I can see who operate on that band. It's very rare you hear a T9 note on that band unless it's real line of sight. It's always got something happening to it. It's spreading, it's moving about. There's extra copies of it. And you get more and more multipath as the frequency goes up. And as I say, it's just pure physics that causes that. Now, we thought, let's have a go at something really interesting. Let's try FT8 on 10 gigahertz. So Sam and I decided we were playing on the Wednesday night Digifest, and Sam and I both have a non-line of sight path of about 80 kilometers over the Suffolk Alps. So it's very, very much a non-line of sight path, and we get, but we work each other 24/7. So it's mainly troposcatter with the odd bit of aircraft, and we both run a few watts on 10 gigs. So we tried FT8 on 10 gigahertz. After we tried a few others, so we put the carriers up, we got it set, going. You could hear the tones, beep, 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 backwards and forwards. Not a single decode. So we had a look at it on a spectrum diagram. And the received signal was wider than the spread of the FT8 tones. And it failed, and that was Sam's expression when he realized what he'd done. It failed, but then we switched to one of the modes that's designed for this. We use JT9F fast, and I'll talk more about this later. It worked perfectly. We had an exchange of QSOs, and we even had a QSO with 5-second overs. And the QSO went dump, 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 and that was gone. But this is a big problem. This is an extreme example of what Neil was talking about yesterday. We had a signal that was about 50 or 60 hertz wide, and that was just the carrier, and it was just purely caused by random Doppler spreading. Perfectly good on CW. Sounds a little bit like Aurora on SSB, but it failed. FT8 failed miserably. So the first thing we've learned today is if you've got anything above 2 meters, don't bother trying FT8 unless it's just across the garden to your friend down the road, because you'll find that it just won't work, or you'll get lots of errors. So the question was asked about why JT9F and not FT8 on 1.3 gigs. We have used FT8 on 1.3 gigahertz, and it does work-ish, but it's very unreliable and doesn't do very well. They've both got 15-second overs, but we found it didn't work, so we wanted to dig into it and find out what was going on. That's one of Neil's diagrams of an FT8 signal. 6.25 baud, symbols per second that is. The bandwidth of 50 hertz, but as you saw from Neil yesterday, it's not actually 50 hertz. But 50 hertz is where most of the interesting stuff is. So that's FT8. That's the FT8 signal. JT9 has a number of modes. It's got fast modes and it's got slow modes. So if you try the slow mode, your bandwidth goes up to 15.6 hertz and it's 1.736 baud. So it's very slow. And it works really well for things where you've got very weak signals but no serious distortion. And that looks very similar to that. JT9F, fast. And you've got various submodes. You've got E2H. What they do with these fast modes is they increase the symbol rate to try and match the increasing tone spacings. So you end up, it's our old friend, it's our old friend Claude Shannon again. The wider the bandwidth, the more information you can get down, so the more you can afford to lose. So we started experimenting with JT9F fast. Now, there's certain issues with that, but it works really well on aircraft scatter. It's even with 15-second overs, you don't see a waterfall display on this. You get a display like you get on FSK 441, because the sort of signals you're getting are transient. And we played around with JT4, all the various modes. We played around with JT65, but then we discovered JT9F fast, and everybody who comes on a Tuesday night generally is using this now. And if they don't, we very rapidly educate them by going, stop using FT8. And it works extremely well, and it works right up to 10 gigs and probably beyond. I haven't got a QSO partner for 24 gigs from home, because one of the problems with 24 gigs is you have to live west of the Greenwich Meridian to go on that band, unless you're me. And so all the activity on 24 gigs is west of the Chilterns. So unfortunately, it's just a no-starter for me. Sorry, Noel. Noel very kindly drove all the way to Dunstable Downs to try and give me a new square, and we still failed. But so I've not seen much activity on 24. So the thing about JT9F, as opposed to FT8 and things, is the message durations are much shorter, and they're sent repeatedly through the sequence. But again, I know FT8 does that, but this does it in a better way that's suited to the gigahertz bands. But the problem is you start to increase the bandwidth, and it's not as I'm going to be careful what I say here. It's not for lazy people who just want to tune to one frequency and sit there clicking. Yeah, you have to actually make an effort to have a QSO with FT8. You have to find a frequency first, and I'll explain why as we come along. But this is a sort of experimentation we were doing on a Wednesday night, and I'd invite people to join. JT9F uses 50 baud keying in a 450 hertz bandwidth. So you can immediately see that it's a much wider signal, and you're not going to start squeezing 60 contacts into a 3 kilohertz band. But it does get over a lot of the issues with fading. Because of the wide tone spacing, it fixes the Doppler and spreading problem, and it does work extremely well. It's 9 times the bandwidth of FT8, mainly because of the wider tone spacing and the speed. It's much less susceptible to multipath spreading, so you can work it over the most spread. Rain scatter paths are, rain scatter on 10 gigahertz sounds like Aurora. He's gone. Oh, you're still there. Sorry, I thought I was... I could bore for Britain, I'm afraid. It's less susceptible to multipath spreading, and it repeats its messages over the 15-second over. So if the first transmission doesn't happen, the second one does, and the third one, and you do get the information through. It's more reliable on paths where you've got very short bursts, like aircraft scatter. I've not tried it on meteor scatter. I don't know whether John has. Have you tried JT9F? No?
No, but I think it might work on ionoscatter on the lower
Yeah.
VHF bands.
Yeah. I'm not sure what Joe actually designed it for, but it seems to work extremely well on this. So, experiments are beginning to show that while it's adequate, FT8 is beginning to struggle with Doppler and multipath, and Neil showed that quite clearly yesterday with some of the issues with decodes. So if you really want to push the envelope, try using some of these other modes. You won't just be able to sit at your computer and go over bath and come back and have worked 5 QSOs, but at least you might start working something more interesting than an S9 signal. So just to give an example, Neil showed similar slides to this yesterday. In fact, one of them I think is the same one, but that's what FT8 looks like on 20 meters. It's exactly what you'd expect. It takes up a little slot and everything's tickety-boo and it decodes, and you sit there with 60 signals on the channel and you sit there clicking away, and it's great fun. If you look at FT8 on 2 meters, and a lot of... this photograph was taken, I don't have a 2 meter beam up at the moment, so that was taken with just a vertical and looking at somebody from a distance. But is that the same signal? Is that the other thing? So FT8 is really struggling even at 2 meters. So don't believe everything you say. Yes, you'll have lots of contacts on FT8. They've worked down into D4 on FT8, so yes, it does work. But if you really want to do some weak signal stuff, try something different. John's about to say something.
No, keep going.
Oh, okay. He's saving it all up to the end so he can shoot me down. So, a few of the things that people have asked me. With FT8, I can see 20 QSOs at a time on 80 meters, and they all decode. And I tried JT9, and even though I could hear it and see it in my fast graph, it didn't decode properly. Well, the reason for the first thing, with FT8, each QSO takes up about 50 hertz-ish, if it's set up properly. So in a typical 3 kHz SSB bandwidth, you can fit 60 QSOs in. With JT9F fast, the number's about 6 QSOs. So you'll find that generally there's not enough activity yet to actually see what happens when you get 6 people working on the same channel with slightly different shifts. So I would appeal to some of you, anyone who's got 23 SEMs, that should be maybe something we should try when we get enough people. But in general, people will do a 1-3 kilohertz per QSO type of thing at the moment. But it's worth experimenting with that and see. So one of the things you can do to improve things, if you are on one frequency, you can set single decode in the settings of WSJT. There is a thing to tick. It doesn't try and look for multiple decodes. It just says get a single decode and decode it. And I'm told by the experts that actually improves the decoding. So that's what tends to happen at the moment. But it would be really interesting to experiment and see what happens when you try and do 6 QSOs or 5 QSOs on one channel. We compared JT65, JT4 on aircraft scatter, but we found again, this is JT4F, I think, and you can see that is probably the original signal, and that's the Doppler shifted version. But again, it worked. JT4F is very good with spreading, but it's less good with big Doppler shifts. Works very well on EME where you've got widespread signals. But JT9F fast, and it worked at 5-second periods, and it's such a buzz working a 5-second period over where it goes clunk, 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 clunk and you're done. So that's aimed at the people who don't like to put too much effort into a QSO. They can, they can have it over in 5 seconds and go make a cup of tea. Sorry, I'm being cynical again, aren't I? JT9F supports auto completion, and that's very helpful with where you've got a short duration path like an aircraft scatter. And until I discovered that tick box, it was a case of, oh, there's a decode, oh shit, I missed it, and it's too late. But you can just set auto decode, so I can set up a sched with somebody over the horizon. I can stick auto mode, and you can just sit there, both stations just sending, exactly the same way as commercial meteor burst systems work. They just send signals continuously until they see one. As soon as a signal comes in, it says, oh, a signal, stop everything and decode. And so you can actually walk away with this, from this, if you have a QSO partner and come back and find it completed. But you really do need to keep your wits about you to use it with autocomplete, because the automatic QS, it's so quick that it can happen before you've realised. A couple of things that it took a while for a few people to realise. There are two buttons. There's one button in WSJT-X which is enable VHF, UHF microwave frequencies, because the first few weeks we were doing this, and so people said, what version of have you got? And we said XYZ 1, 2, 3. They said, yeah, I've got that, but I haven't got fast modes. Have you ticked that box? The fast modes don't appear until you tick that box. So that's the other thing. And the other one is tick this single decode box as well if you're just having one QSO. If you're going to try with more than one, you can leave that unticked. You can tick auto sequence. Is down here. Tick fast mode there, and you can set the transmit receive timing there. 15 seconds is the default, but you can set it right down to 5. It's not too clever if you've not got very good sequencing though, or you've got relays that go ka-clunk. But 5-second modes are quite possible with the right sequencing. So there's a few settings you need to look at. You need to look at when you join us on a Wednesday night. Most of the activities around 1296.165 and 2320 and 2300.165. No competition. Nobody's going to shout at you if you do anything wrong. It's a relaxed evening that starts about 7 and finishes when everybody gets fed up. And you're basically out there to play with digital modes and see what you can do and see who you can work. But you do have to be careful, because you click and it's, oh, right, it's happened. It's not very personal. All these digital modes are a bit impersonal. But the nice thing about digital modes on this and on EME is, because you've got time to think about things, you tend to be chatting backwards and forwards on some sort of reflector somewhere, and you've time to set things up and think about them and try different headings. We've done all sorts of interesting experiments. I live in about 50 miles east of here, and if I beam at the cluster of aircraft over Heathrow, and I just call CQ in that direction, I will get replies right from the north of England right round down to the southwest if you run enough power. It's amazing. So you can actually call CQ if you pick the right direction. There's also a line of aircraft that goes up the northwest of the country from Heathrow up over Greenland. And there's a line of aircraft between me and GI6 680Z such that we can chat on SSB, and it's just continuous aircraft scatter, but it works on these modes as well. There's quite a few stations involved. This was from early last year, and you can see there's quite a good cluster right out to Andreas DJ5AR, who runs a big signal out near Nuremberg, and most people in the East can work, and Andreas on 23 SEMS. There's a few people up in Scotland. This guy, which I think is GM8IEM, he's a real challenge because he's beyond aircraft scatter distance for me. You've got to remember that where I live, I'm much closer to the German border than I am to the Scottish border. So DX for me is working over the Scottish border. But there was quite a bit of people geared up, and I'd like to try and get it going again on Wednesday night. As I say, I've just not been able to get on this summer, but I'm going to start doing it again. So, just to sort of summarise, because there may be a few questions. They add value to the gigahertz bands by, it's really good for working weak fading signals. It allows DX when other modes fail. It opens up the DX to non-CW operators, but you need to choose the right mode for the type of propagation you're trying to do. And it also, because there's quite a few big stations on, a lot of the people are actually, Andreas runs a 3-meter dish, so a lot of small stations, I've worked at a station in Holland with 10 watts and a single 23 element on 23 SEMS quite easily. So it opens it up for some of the smaller stations. But a few words of warning, well, I don't do wisdom, but there you go. The commercial world wants our gigahertz band. They have the money to buy it, and they do. And if the regulators see that we're happy to squeeze everything we do into 3 kilohertz, they'll say, what are you complaining about? You're all on the same channel. Why would you want 2 megahertz? So I'm saying this as a word of warning. Don't get so digital mode obsessed that we suddenly don't have any bands left, because it's not going to happen at HF. Nobody's going to take your HF bands away, but they are going to take these bands away if it's found that there's not much use. So unless you want to be ready with an empty room, be careful. And I'm not exaggerating. I do tend to exaggerate sometimes, but it is a bit of a battle of survival on these bands. Countries like Sweden have already lost 13 SEMS, as good as. So start using wideband modes. And we look to people like Simon and other people to come up with, let's have some nice wideband modes.
Exactly what I was going to say.
Yeah, please, all you clever software guys, let's invent some nice wideband modes. I've started doing DATV simply because I want more signals on the band. And if you talk to Murray Nyman, the Spectrum Forum head, he's been banging on to me about this for ages. Stop pushing narrowbands, John. Let's make some interesting wideband modes. And this is where the BATC guys are giving the lead. Use Digimodes to make QSOs you couldn't make on wideband, like small dish EME, like small station 23 SEMS. And experiment, experiment, and experiment again. Don't just make it a chat. If you want to chat to someone, get your phone out. Do some experiments, right? Improve your systems, because one of the things that I did with EME, I started off on digital modes, and then Peter G3LTF says, oh, I can work you on CW. And I said, no. I've worked something like 25 CW initials on 23 SEMS with a 1.9 meter dish and 200 watts. But I did that by improving my digital system. So improve your digital mode system, and suddenly you find you work these guys on CW, and you fill the bands. Use DATV. We have to be seen to fill in our spectrum. And anybody who reads my column will know that I bang on about this forever, but it's absolutely true. I mean, I've talked to the people at the sharp end, and so has John. We won't have any left otherwise. So join the Digifest. Thank you.
Thank you very much, John. I'm going to use the chairman's seat, because with my other hat on as the RSGB VHF manager, amateur radio is a battle survival on all of our VHF, UHF and microwave bands. That includes bands that you don't think are under threat, including 50 megahertz, which is up for discussion at Walk 19 next year. And there are some administrations that have monitored 50 megahertz, and all they see is activity on one channel in their monitoring. It is also just as true on 2 meters, 70 centimeters, 1296, and all the way up. That was the first point. The second point is, I can't see Stuart G3YSX in here. Amateur radio needs a new bearer network mode. And it doesn't matter whether it's for voice, because we have falling activity on simplex and repeaters because we have too many modes that are incompatible. VHF, UHF, and on 23. I get requests for more repeaters. Why? The activity on each one's going down like a stone. And we need more innovation. The one thing that has been my saving grace in dealing with Ofcom over the last 4 or 5 years is I did a presentation of high definition DATV on 146 megahertz in front of Ofcom and the business users, and they were just totally gobsmacked. And I only had a 10-minute slot, and it ran to an hour, and they cancelled other people out of the thing. So all of that is true, but I just say on all of the VHF bands. I have the first question for John. JT9F, does it have the same level of forward error correction that some of the other modes that are used for EME, such as JT65 has?
I don't know. Simple as that. I don't know. Does anybody know?
Does anybody know?
Ask Joe, he'll tell you.
He doesn't speak to me anymore.
I wonder why.
Right.
No, I'm not sure, but I'm sure if you dug around in the information, you'd find it. But it works like a dream on 23 SEMS with aircraft scatter.
So, questions, so I don't hold the floor.
Simon.
Let me get the mic up there.
Thank you. Quick question. If you're doing 5-second intervals, does it start to kill relays? And what's the system engineering?
Yes.
Because I won't mention 10 gigahertz and relays.
No, and relays. Yes, you have to be careful. I wouldn't run 5-second overs on a regular basis. We did this on a Wednesday night, inverted commas, for a laugh. But it does work. But if you've got relays, and especially if you've got relays like that one on my EMI dish, which goes clunk every time it goes over, no. But it does. It's just numbers. There's more transitions, and you have to get the timing right.
And if you think about it, some of these relays are only rated for 100,000 operations.
Yeah, and a lot of the relays...
And a lot of them surplus and have probably had more than half their life done. So you can kill your relays quite easily.
Yeah, yeah.
Any further questions?
This is more of a suggestion than a... Sorry. This is more of a suggestion than a question. I use 2 meters. I've done the UK activity stuff and all that sort of stuff. And I listen quite a lot and occasionally call CQ, and there's nobody there. And I think, isn't it not possible to have, you're talking about a Wednesday night digi thing for 24 gig. Is it not possible to have a...
23 cents.
23 cents,
yeah.
Sorry. Is it not possible to organise sort of QSO parties, really? I hate to use this American thing.
There's a guy called GHz who's really keen on this, and I think he should probably organise one.
Well, it requires more
I'm
than
sorry
that,
to be so direct,
no, I know
but the
exactly
number
where
of
you're
people who say to me, can we have this? And I say, well, what do you need to set it up? Set it up yourself. I set this up myself. I put things out on social media and I said, I want to try and get things going. You can't sit back and ask for somebody else to do it.
And
I'm sorry.
And to get that along, if you want to do the gigahertz band, you email John, or if you want to do the VHF bands, UHF bands, you email Rich at G4HGI.
Yeah,
and
set it up, start it off.
You start it off, and those guys will help you with the publicity.
Yeah, I'm sorry to be so blunt with you, but the number of times I, as a columnist, get said, "Why don't we do this?" And my response is, "Who's this we?" You're the enthusiastic person that wants it, so do it.
I'd hate to see the 2 meters taken away from us.
Yeah. Yeah.
But there's got what I'm looking for is a reason to get on the air.
Yeah. Well, this is why I said let's use digital modes. So why not do a 2 meter digital modes QSO? Because everybody else is on them already. Yes.
No.
Sorry.
Quite seriously. Most of you don't see what happens on the far east of the country, but to raise activity in newcomers and the rest on the VHF bands, Essex Ham have FM activity days on Saturday.
Yeah.
And that sort of thing is organised at a local club level and then publicised. But it needs people on the ground to start it.
It's all about publicity. I'm a very good friend of Sam G4DDK, and we jokingly call each other shameless self-publicists. You have to be one. If these things are going to happen, the classic example of this is I was here on Friday with 20 other people. I wanted to learn about GNU radio, and I had no idea where to start, so I decided to organise a course. And suddenly, 2 people came up and said, "Oh, I'd like to do that. I'd like to teach on that," and it happened. You can't... I used to work with a guy called David Armand, who was a managing director of the company I worked for, and he used to say to his staff all the time, "Will you please not sit there like baby birds in a nest with your beaks open waiting for someone to pop a worm in? For God's sake, do something."
And the expression is JFDI. I'll do the next question with Paul.
Okay, we want Paul Nichols, G8AQA. We want to use more spectrum. Are we allowed to use spread spectrum techniques?
Yes.
And will it be a problem because no one will hear us when they're listening conventionally?
Well, yeah, this is one of the good things about what SDRs are doing for us now. A lot of people have used SDRs with blinkers on. They've seen them as another way of doing SSB transmitters and CW transmitters. Why not get hold of GNU radio? And it takes about 15 minutes to create. You could create a GMSK 2 meter station. It doesn't take long once you get over the initial horror of software.
You can use almost whatever you want on any amateur band. That with spread spectrum or anything else like that, the only thing is that you mustn't use what used to be termed a secret code or cipher to put confidentiality on it. You can put everything else on.
Yeah,
I'm having my fingers waved at me. Oh, he's got a question.
Oh, he's got a question. No, we've got 2 minutes, yeah?
Yeah, just a quick one, John. Some good screenshots on there. Are they available on the Microwave Wiki? Because that was the biggest problem I found. We need a dummy's guide to getting this thing on the air.
I will put this presentation on the Microwave Wiki and on my website. All my presentations end up on my website eventually, but I need this thing called Around to It to finally do these things. But yes, they will be on the website. They'll probably be on the RSGB YouTube channel, possibly as well. I don't know whether I'm being videoed or not.
It'll take a time before they appear on the RSGB YouTube channel.
But I'll put these on my website next week.
So, thank you, John, very much. John brought out something that's been a theme over the last 2 days here on the VHF and Up theme, is actually, as Bo OZ2M put it in his talk on PI4, finding the right footwear for what you want to do. I, being cynical, put it the other way round, saying don't wear the wrong trousers, that I took from Andy Talbot. But digital modes can work, they can be effective for amateur radio, but you have to use the right ones, and learning how to use the right ones is very much part of amateur experimentation and propagation. So thank you very much, John, and we'll see you all again at 1:30 for the next talk.